In this video, we're going to talk about the domain and range of the logarithm. So let's quickly review what domain and range are. Domain is the x values of the function. It's the inputs that you're allowed to put into your function. Range is the y values of your function. It's the outputs that you get out of your function. All right, so again, these are just definitions. You kind of have to know domain is x, range is y. All right, a lot of times we're interested more with the domain because we don't want to put things we're not allowed to put into a function. Range is really helpful for application problems or word problems. We're going to make sure we're getting out values that make sense. All right, so let's look at the graph of log base 2 of x and figure out the domain and range. All right, so we know they're x values and y values. So we talked about the graphs. All right, logarithm graphs have this vertical asymptote here. They have the point 1, 0. And then because 2 is a bigger number, it's kind of hugging the vertical asymptote on the left, on the bottom. Man, keep messing up everything. And then curving through that point before it goes up. All right. So let's start with range. All right, what does the range of this function look like? What y values are we hitting? Well, we're very obviously hitting all of these negative y values down here. We're hitting these positive y values, and you might think like, okay, we're not going to hit this value because this kind of goes slow. But this logarithms are really weird in this way, is that they keep going and they kind of look like they level up, but they're always going very, very slowly upward. So this graph, it might take a really long time as it very slowly goes upward, but eventually it's going to hit this y value. And much later, it's eventually going to hit this y value, and it's eventually going to hit this one. So even though it doesn't look like it, eventually I'll hit all the y values up here as well. And the range of my function is all real numbers. All right, again, you don't have to use the fancy double-lined R. You can just say range equals all real numbers or something like that. And I'm not too much of a stickler for the notation you use, as long as you're putting in words or doing the right thing, as long as you know the range of things you get out of this logarithm is everything, then I'm happy with that. All right, and what about the domain? All right, the domain is the x values. I'm hitting all of these positive values over here. And we talked about this when we were learning the graphs. There's just nothing over here for my graph of my logarithm, which means there's no negative values for my logarithm. So my domain is all the x values that are bigger than 0, right? I'm not getting any of these values. And then the important question is, should I put an equal sign under here or not? If I put an equal sign, it says I can plug in 0. If I don't put an equal sign, it means I cannot plug in 0. So which one is right? We have this vertical asymptote here, and you never actually touch the vertical asymptote. You just get really, really close to it. If you were to like zoom in on the vertical asymptote, there'll always be this little tiny gap between the two, depending on how far you zoom. So we can never actually touch that vertical asymptote at 0, so we actually do just leave it like this. We don't want to put the equal sign here. We just want to leave it strictly bigger than 0. All right, so for a general logarithm, the domain is everything that's bigger than 0. The range is always going to be all real numbers. And again, I could always create a logarithm whose range isn't all real numbers, but the ones you'll be dealing with in this class, the range is all real numbers. All right, so now let's look at this graph, log base 2 of x minus 5. Let's find the domain and range by graphing it. All right, so we have our original log base 2 graph we just had on this previous slide. And all it's going to change in this one is I'm going to shift it to the right 5. So my vertical asymptote is going to change. 1, 2, 3, 4, 5. Let's make that red like I always do. And then I have the same graph that's kind of hugging my vertical asymptote at the bottom before it turns out through that point. All right, so again, even though eventually it'll look like it levels off, we know our range is all real numbers. That means everything. What is my domain going to be? We know I can't hit anything to the left of this vertical asymptote, so my domain is going to be the x values that are strictly bigger than 5. Because 5 is kind of this border between the values I get and the values I don't get. All right, so quick summary. The range of logarithms is the easy one. It's just all real numbers. So you can pretty much just say that without thinking about it for right now. And the domain of the logarithm requires that the inside of the log is strictly, which means it's that not with the equal sign, strictly greater than 0. So now I can give you slightly more complex functions. We actually don't know how to graph, but we can still do the same thing. So we see a logarithm, we're asked for the range, we just say the range is all real numbers. Nothing else you need to do. Domain is going to be more complicated. What we have to make sure for the domain is that the inside of the log, whatever I end up plugging into my logarithm, has to be strictly bigger than 0. So these are similar to square root questions we did a long time ago. We take the inside, we set it strictly bigger than 0, and then we can just solve this for x. So we subtract 8 from both sides and divide by 2. All right, so my domain is the set of x's that are bigger than -4. Right. So if I plug in anything bigger than -4, it forces inside of this parentheses to be positive, which means I can actually plug it into the log. If I tried something smaller than -4, like -10, that would give me -12, and I wouldn't be able to plug that into the log because I can't plug negatives into a logarithm. Right. So this is the general strategy you're actually going to be doing when you're solving logarithm, domain, and range questions. All right, domain and range of this logarithm, hopefully you know now the range. What should that be? It's all real numbers. And then what is the domain going to be? The domain, I got to make sure the inside, whatever is inside the log, is strictly bigger than 0. In this case, I can subtract 16 from both sides and then divide by -2. All right, one thing to remember whenever you're working with inequalities, whenever you multiply or divide by a negative, this switches direction. So instead of being greater than, now it's a less than. All right, so my domain is all the x values that are less than 8. So as long as I plug in something that's less than 8, it's fine for this specific logarithm. We haven't talked about how to graph this by hand. But if you did, you would actually see that the asymptote is here and the log's actually on the left-hand side, like that. All right, so here's one for you to try your own. Find the domain and range of this logarithm. All right, I'll show you the answer in 3, 2, 1. And I really hope you got this one right. All right, the range is all real numbers. For the domain, it doesn't matter what logarithm I'm talking about, base 100, base 1/3, base 2, whatever. It always just matters whatever's on the inside of your logarithm is strictly bigger than 0. I subtract 10, divide by -5, and remember when I divide by this negative here, this greater than becomes a less than. So my domain is everything that's less than 2. Right, so quick summary, the range of a logarithm is all real numbers. All right, those are the easier parts of logarithms. And the domain is found by setting the inside strictly greater than 0. All right, so make sure you don't have the equal sign underneath of your inequality.